Great. I hope everyone's doing well. It's only the first week back, and so we still have our energy, right? Still feeling good and optimistic. All right, so we'll continue talking about data structures. Last time we talked about atomic vectors. We said everything has to be the same type. And then we had the integer ones and double and character and logical and all of that. And then we talked about how they get coerced into other stuff. If you wanted different types, you use a list, and then we started just mentioning attributes. And as far as attributes go, the only one we really covered was names. Okay. All right. We can talk about other quote types of or the way R stores information, and one of these is a factor. Okay, and so factors are like our vectors, but they are set so that they can only contain certain values, predefined values. So only certain options are allowed. You can't pick, like when you go to the car dealership and you say, I want this color, probably purple is not a choice. I mean, maybe for some vehicles, but usually it'll be like, okay, you can have black, white, silver, red. I don't know how many colors cars come in, but usually they only have maybe like 5 choices, and so that's that. Okay, and at the dealership they might have funny names. They might call this like metallic silver and like spaceship black, or I don't know what they would call these things. It just makes sense to just say the person picked color choice 3 or something like that. Okay, and that's effectively what a factor in R does. Okay, it says here are these defined values, but rather than having to store the entire name of the thing, we're going to store these things as essentially an integer vector. Okay, so I'm going to go ahead and I'm going to create a factor in R. Okay, so I'm going to say x is a factor, and we will say it's we'll take the letters A and B and B and A. Okay. All right. So we ask x, what is it? And look, it says it's A, B, B, A, and here it says levels are A and B. And if you look over in the what do we call this? The environment viewer, it'll say, oh, you've got this factor with 2 levels. Okay. If we asked what is x, okay, the type of, we see it is actually stored as an integer. Okay. And then we have this thing called class, and it will say it's a factor. So the way that the object type that exists in R, it's designated as a factor, but it's really underneath it, it's an integer vector. So if we said as.integer x, these things are actually stored as 1s and 2s. Okay, it's actually stored as 1s and 2s, and we can actually see that. We can say structure of x, okay, and it says it's a factor with 2 levels, a, b, but underlying it's really just 1s and 2s. And what R is doing is it says every time I see the letter 1, I'm gonna go into this thing and say look up what 1 corresponds to. Oh, 1 corresponds to A, 2 corresponds to B, and things like that. Okay, and so we can ask what are the attributes of x, and it will say the levels. Okay, so effectively when you have these 1s and 2s, it's looking up in the levels which one is which here. Okay, and the class is a factor. Okay, and later on you can see how all this goes. The important thing is underlying the factor, it's an integer vector, okay? Okay. So the thing about factors is that it's not going to let you put in values that are not part of their predefined levels, right? So if we look at the attributes of x, the levels, allowed levels are a and b, and so if I say, if I want to replace the second element in x with a c, it's going to say you can't do that, and we have only, we put in an, it spits back in NA, okay? Whereas, you know, if I wanted to put in the A, it's happy doing that, okay? So you can replace things in the factor as long as that level is allowed, okay? Now we could, the levels of x are a and b. I could change this so that the levels of x are a and b, oops, and c, okay? And then so now if we look at x, it's still AABA, but now the c is now an allowed level, and so I can go back and I can say put in c for the second element, and that will accept it, okay? So as long as it only accepts values that are programmed into its into the allowed levels there, okay? But again, you know, it. So here, you know, okay. So that's what happens. You can't combine factors the way you would combine vectors, okay? And so, you know, if I have something defined as factor A and another thing defined as factor B, and I try to combine them, effectively what happens is it sees, oh, you've got, over here we've got an integer vector with just one level, right? And over here it's another integer vector with just one level as a factor. And so when you combine them, you get a 1 and a 1. It's combining the integer vectors. Yeah, question?
So you need to include the level first before you...
Yeah, you know, okay, so if you want to combine factors, the way you should do it is convert them into a character vector, and then combine the character vector, and then turn the character vector back into a factor. Okay, that's probably the way you would need to do it. Because if you tried to just combine vector, because what you would have to do, it would be complicated. Like if you had a complex factor over here and a complex factor over here, you'd have to like look up what each integer value corresponds to, make sure that the levels are all, you know, find the unique set of levels between these two things, which may or may not be the same. And then, so anyway, combining factors, just turn them into characters and then do it, okay? So less headaches, okay? All right, so it says factors are useful when you know the possible values a variable may take, even if you don't see all the values in a given data set. Using a factor instead of a character vector makes it obvious when some groups contain no observations. Okay, so here's an example. So you know, maybe we're keeping track of the sex of some people, and so here we have seen 3 males, and we can say we're going to create a factor where there are 2 levels, male and female. Okay, and maybe, you know, I recognize sex or gender might be more complicated. Maybe we have a non-binary or something in there, but you know, if you define it as such, okay, if you just use the function table. So the function table goes through a vector and it tabulates the values that it sees, okay? And so here it would say, oh, I see 3 values of m, okay? And it says m3, okay? Whereas if you tell it to tabulate the factor, okay, it says, okay, I see 3 m's. Oh, what do we have? We got a level called f, and I don't see any of those, and so that will appear in the table down here as well, okay? And so so factors have their use, okay? Sometimes we end up getting things turned into factors and we were not expecting them to be factors, okay? So maybe you were anticipating something to be numbers, okay? And so you know, let's say you had a bunch of numbers, and when you import it, it doesn't. It's not a factor. I mean, it's not numbers. It got turned into a factor, and you're like, what's going on here? Okay. What often happens is that maybe usually when this happens, the biggest problem is that one of the characters or one of the values was missing, and you have something like a dash in its place to indicate that it was a missing value. Okay, and so when R is importing it using something like read.csv or read.table, it's going to see that character that's not a number, and it's going to say, oh, never mind, these aren't numbers. I'm gonna turn this into a factor. Okay, and then you know, if you have something stored as factors, you can't do mathematical operations or things like that because, you know, R is going to get angry at you. So, you know, let's just say, you know, let's say, we'll just do. Okay, so, you know, J looks something like this. Okay, so, you know, I could do when you import something like this, you know, you might get something like this. All right, and you were expecting the numbers, but because you had a missing value, it got turned into a factor. Okay, and so like if you wanted to ask, you know, what's the mean of J, it's going to say you can't do this, right? Or if you wanted to just add 2 to these things, it's going to say this, we can't do this, right? And so so one way to fix this, okay, is you'd have to do as.character. You'd turn this into a character vector, okay, and then so I'm going to store this as k. All right, and then so k is this character vector. We can replace the missing thing with an NA. Okay, so now I have a character vector with this, and then we can do turn this back into a numeric vector. Okay. Okay, and then so now I can do k plus 2, and that works. And if I can ask for the mean of k, but then oops. Okay, and we can do computations this way. Yes.
And like if the vector that like originally instead of a dash, if it had an NA to begin with.
Yeah, if it has an NA to begin with, it will recognize it as such.
As it is, so it'll be like an
integer. Yeah, it'll so yeah, so when you do something like read.csv or read.table, or you're reading in a file, there is an option to say na.strings, and I want to say it's smart enough, or it defaults to recognizing na as na values, but you know, again, if it does something unexpected, just go through and just make sure you've defined the options as necessary. Okay, and so so one of the things, yeah, when you do something like read.csv, you can use na.strings is equal to either the dash symbol or na or whatever it is, however it's being stored in the data, and then and you won't run into that problem. Okay, so that's a better way to go. But you know, if you have something stored as a factor, one way around it, okay, if you have numeric values stored in a factor, then one way around it is to get them turned into characters, and then convert the characters into numbers. Okay, so again, so k now works, but okay, j is the factor, and if I did as.integer j, okay, notice that the dash is stored as the 1, okay, this is stored as a 2, and this is stored as the third thing. Okay, and so when it gets coded, if you just did as.integer j, the values don't match up, right? The 1 is stored as the 2, okay? The dash is stored as the 1, and then the 10 is stored as a 3, okay? And it's because this is like, it's using kind of like alphabetical order rules for the numbers, okay? Even though that seems silly. I think we've all experienced something like where 10 comes after 1 but comes before 2, like when the computer sorts things. I think Windows has gotten smarter where it's like, oh, 10 should come after 9. But for a long time, when you had like a bunch of documents and you have like the number 10 in there and everything else, it'll go 1, 10, 2, and things like that. And R still does that. Yes?
So for there, did the dash become 4 because that was the only missing number?
Yeah, so the missing number, the dash got coded to a 1 in alphabetical order. Like if you put these characters in alphabetical order, the dash comes first, and then things with a 1 come next. And then, you know, it's odd thinking of putting numbers in alphabetical order, but this is how you would put numbers in alphabetical order, right? So, you know, it's not good to just say, oh, well, I'll fix this problem by doing j as a factor. I'm going to turn it into as.integer because it's stored as an integer. This is no good. Okay, you got to do it character and then convert it. So, all right. Okay. Yeah, and then so probably the culprit of these problems is this thing called strings as factors. Okay, so this is when you read in data from something like read.csv or read.table, or even when creating a data frame, there's this option, and the default setting is strings as factors is true, and it's basically takes string data and it turns it into a factor. Okay, and we don't generally, this is not something we want to do. So you should use the option strings as factors equal false. Okay, so if you did something like read.table, and we asked questions about this, okay, the default setting for strings as factor is the default on your system. Okay, so it is possible to change the default setting on your computer to be strings as factors false, but I would recommend against that because when you start changing the default settings on your computer and you send your code to someone else, it's going to break because they're going to have different default settings. So you should just explicitly say in your code strings as factors equal false, and that way when you send it over to someone else's computer with different default settings, strings as factors equal false will be explicitly in there. Okay, and that preserves strings as strings or character data. Okay, so factors versus characters, they look similar, but they're different. Characters are character data. Factors are stored as integers, okay? And the reason for this was back in the day, you know, we had computers with limited memory, you know, maybe like 1 megabyte of memory. I remember my first computer had 4 megabytes of RAM. So, you know, and then my hard drive had 30 megabytes. And so anyway, you know, these were, you wanted to have these memory advantages by storing things as integers, and and that was that. Okay, today it's not a problem. You know, you have 8 gigabytes of RAM or 16 or whatever. So whatever, these things aren't that big of a deal. And all of these different things work very differently, such as just the combine will throw an error, or I'm sorry, combine will use the underlying integer values, and character, which tells you the number of characters, will return errors, whereas other things will coerce them into strings. So anyway, just be careful when dealing with factors. Factors can be useful, but they can also be a source of headaches. So a lot of times it's easier just to deal with strings. Okay, On the other hand, we have matrices and arrays, okay? And so matrices, these are essentially atomic vectors with a dimension attribute, okay? They are stored internally as atomic vectors, but R handles them differently because they have a dimension attribute. And so the thing about atomic vectors, the most important thing is that everything, all of the elements in an atomic vector have to be the same type. And that is going to be the true same for matrices and arrays. In a matrix or an array, everything has to be of the same type. Okay, we don't. They are handled the same. I would say matrices are far more commonly used. There's like been a long history of like matrix algebra, like linear algebra, and all of that stuff. Arrays use the same principles in effect, but you know, we don't see them as much. Okay, so let me kind of clear out these things here. So let's say, you know, X is a vector with 20 elements. Okay, so this is an atomic vector, right? Is atomic X, yes. Okay, we can say type of, and this is going to be integer, right? We can turn this into a matrix. Just if I ask the dimensions of X, currently there are no dimensions. It says null. Okay, I could take. I can say, okay, now I want to put a dimensions attribute. I could say I want 5 rows, 4 columns. Okay, we're going to throw this into the dimensions of X, and then suddenly X is now a matrix. Okay, I ask X, and now it's a matrix. If I say type of X, it still says it's integer. The underlying information is still integer data, whereas is it atomic? I'm sorry, that's true, meaning that everything has the same same type, but the class, if we asked X a class, it will say it is a matrix, okay? Whereas class of something 1 through 20, this will just say it's integer here, okay? So now this is a matrix. If we say is X a vector, it is no longer true, okay? So it's no longer a vector, it's a matrix here, okay? And you'll notice that the way it populated the matrix is it goes down. It goes 1, 2, 3, 4, 5. It goes down each column, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth, okay? We could just change the dimensions. I'm sorry, not. Again, the dimensions of X are 5 rows, 4 columns. I could say the dimensions of X, I now want to have 2 rows, 10 columns, okay? And it's effectively just taking the underlying vector, and it's just going to populate the matrix this way, column-wise, okay? So let's look at that. All right. So we have this, okay? Okay, oh, and we can do an array in a similar way. All right, so 1 through 27, we can do this. So an array, we can take 1 through 27, and we can say the dimensions, we want 3 by 3 by 3. Okay, and so this is, I don't know, do you guys ever play like 3D tic-tac-toe? You get your 3 by 3 grid up there, and you have 3 of those. And so, you know, your second 3 by 3 grid appears here, and your third 3 by 3 grid appears here. And again, the way it fills out is in the order of the dimensions, right? So it's going to go down here, 1, 2, 3, and then once it fills this out, it goes to the next one, 4, 5, 6, 7, 8, 9. And once it's filled, you know, the 3 by 3, then it goes to the third dimension and starts populating them that way. Okay, so you're going to do this, and you know, you could create an array with 4 dimensions, okay, 3 by 3 by 3, and this is a little bit harder for us to visualize in our head, but effectively you've got this 3 by 3 cube and another 3 by 3 by 3 cube and another 3 by 3 by 3 cube. Okay, so yeah, question.
So the third number, it creates like 3 different, or in this case, so could you like explain what the third number does?
Which one?
Well, like in the concatenation, it's like 3, comma 3, comma 3, comma 3. I kind of get lost after the.
Okay, so this is the first dimension and the second dimension. So first dimension would be the number of rows. This is the number of columns. This would be the number of layers. And then this one would be the number of prisms. Right? I don't know, whatever you call this rectangular prism thing, right? So this is, you know, how many rows, how many columns, how many layers per prism, and then this would be how many prisms that you have. And so, you know, this, I guess we could say this is a 4-dimensional structure, like a tesseract or I don't know, whatever. And so that exists. But yeah, yes.
What if the number of elements don't divide evenly?
What if it doesn't divide evenly? Then it's going to complain, right? So if I say 1 through 80, and then I got it 3 by 3 by 3. Oh, I'm sorry, it recycles it. Okay, it just recycles. Whereas, so that last one gets recycled around. Okay. You could also, another option, so I can start off with y as the numbers 1 through 81, and then I could say the dimensions of y currently are blank, but I can throw in, I could say we're going to make a 3 by 3 by 3 by 3 thing, and then now y is suddenly an array, okay? Whereas if you did it this way, and you give it an invalid number of dimensions, so right now x is 1 through 20, okay? And if I said I want the dimensions of x to be 3 by 7, then it will error out on you. Okay, it'll say that doesn't multiply to 20. Okay, so then you got to do 5 by 4, and then it works. Okay. So those are arrays. Yeah, and I showed this to you. I said you can just take the vector and modify it in place and apply dimensions that way. Yes, question.
What's the distinguishing factor between the type of function and the class function?
So the class is the way R handles objects. Okay, so there's this system called S3 and S4, and these are for the object-oriented programming things. And so class will return you the object's type. Okay, type of tells you the, I guess, the underlying storage mode for this data here. Okay, so if we ask, you know, if we ask class of a factor, it's going to say it's a factor. Okay, whereas if you ask type of for a factor, the way it's stored is that it's an integer. Okay. Okay, so here we've got a matrix. So the way because it's an underlying vector and it fills out column-wise, we can keep this in mind when we want to apply operations to this. Okay, so if I did x plus 100, what would this do? It would add 100 to each element of x, right? It's going to take the 100, it's going to recycle it, it's going to add 100 to each of these things. Okay. What if I did x plus 100, 200, 300, 400?
Recycling?
Yeah, and so where is it going to add the 100, 200, 300, 400? It's going to go by column, okay, which may or may not be what you wanted, okay? So it starts up here and it goes 100 to the first row, 200 to this next thing, 300 here, 400 here, and then it hits this fifth row and it recycles back to the 100, okay? And it goes 105, and then over here, the next thing it adds a 200, and then it adds a 300, okay? What if you wanted to go 100 to the first column, 200 to the second column, 300 to the third column, and 400 to the last column? How would we have to do this? If we wanted to do this in a single operation, or I don't know, maybe multiple operations but in a single line. We don't have an option to tell R add it by row. Yeah, what can we do?
Make the non-dimensions with it.
Yeah, so I think the easiest would be to take the x and we would transpose the x, okay? And then we would transpose that result back, okay? So if I transpose the x, then it goes the way we want it, but then we want to transpose that back, so we got to stick that all the way back in here, and there you go. So so now, you know, when we transposed it, it's going to add it that way, and then we're transposing it back, okay? And so you want to think about these things the way R is handling matrices and their addition and multiplication and stuff like that. Yeah, another option would be to create a matrix of a separate one that you can just kind of add up, okay? And that's fine. But yeah, if you want to do it this way, probably this is how I would do it. I would transpose it, add them up, and then transpose it back, okay? Because R can handle these things, you know, quite quickly. It's no problem here, all right? If you ask, so again, x is just 1 through 20 in a 5x4 matrix. If we ask for the length of x, what is this going to return? 20, all right? Okay, 20 elements, all right? And if we asked, if we want to get the number of rows or the number of columns, we could ask for the dimensions of x. We can ask the number of rows of x is 5, the number of columns of x is 4, okay? Here's a question. What if I say length happy? What's this going to return? It's going to return 1, right? It is a character vector with 1 element in it, okay? So this is no different than saying length 100. It's a numeric vector with 1 element, okay? If I wanted to get 5 instead of length happy, what do I have to do? And character, right? Okay. Okay, all right, so we can talk about assigning row names and column names, all right? So if we ask, you know, the names of x, right now there are no names to x, okay? Or column names of x, there's nothing, right? So x is this. So for the column names of x, I can assign the letters A through D, A, B, C, D, E. So I can do column names x, and I can do A, comma B, comma C, comma D, okay? And then so x now has the column names A, B, C, and D, okay? And then so with x, I can reference just column B using that, all right? It doesn't work. It doesn't work this way, okay? This doesn't work for. This works for data frames and lists. It doesn't work for matrices, okay? So for the matrix, you gotta kind of use this bracket notation here to reference a certain column, okay? And we can apply row names in a similar way. You guys are familiar with the letters vectors, installed as kind of like default thing in R. So you got letters and you have capital, all caps letters, and so these are just for your convenience. Instead of having to create A and comma B, comma C, comma D, okay, you can just say letters, give me 1 through 5, or all caps letters 1 through 5, okay? And that will be a vector. It's very convenient, okay, rather than, because this is annoying, right? So, all right, so we have x, we've got given it column names, and we can ask what are the attributes of x, whoops, attributes of x now, and it will say, I've got dimensions, and then I've got column names and row names, right? So but it stores it, dimension names is itself a list, okay? And within that we've got 2 things, right? So I could say, what's the structure of x? And it says it's got this. It's got attributes attached to it, and we could say what's the structure of the attributes of x? And we've got a list of 2, whereas dimensions and dimension names, and the dimension names itself says, you know, for the first dimension it's this, and the second dimension it's this, right? Whereas y, we could also give it some dimension names. Dim names of y right now are null, and we can say, I don't know, if we just wanted to name the third dimension of y, suddenly we have this. Okay, it now refers to this ABC and things like that. So so you can do it that way. Okay, I would say we don't really use row names that often. It's common to name columns in data. You could name rows, but generally I would say row names get stored as its own column for name of the row that you're looking at. But you might want to use row names if you know, you got numeric data, right? And maybe you want to keep it as a matrix. And in order to keep it as a matrix, everything has to be the same type. So you can't mix in character data with into that matrix. So you can't keep the name as its own column. So it might be to your advantage to store the names of each person as the row name, so that the data itself remains as a matrix, if that makes sense. So that might be an option. I don't know. Okay. But that's that. Okay, so we got length, number of rows, number of columns. So you can do the same thing with arrays, and name the dimensions that way also. Okay. Do you have a question here? Okay. All right, we can, if you wanted to combine matrices and arrays, you have cbind and rbind, okay? And so this is combining column-wise or combining row-wise. So you're basically just kind of taping these the matrices together column-wise when you use cbind, or you're taping them together row-wise when you're doing rbind. So right now I got, you know, x is this. I can cbind two matrices of x, and we're going to get that. I can cbind matrix x with maybe 100 through 104. Whoops. Okay, and then that just gets tacked on. And there's no name for this one, so I could name it, you know, j equals this. All right, and it gets tacked on that way. All right, so that's going to be a cbind. Okay, and rbind does the same thing, except it does it row-wise. We can also have one-dimensional matrices and arrays. We're used to seeing things as vectors, but you can also have a row matrix or a column matrix, right? So I could have, maybe I'll make A, elements 1 through 10. This is a vector, right? So I can say, is it a vector? It will say yes. I can ask the structure of A, and it will say it's an integer vector, 10 spots 1 through 10, okay? I can turn this into a matrix, right? I could say, make it a matrix, and we can say number of rows equals 1, okay? And then maybe I'll do C, make matrix A into a matrix, and number of columns equals 1, okay? All right, and then so when I print out B, it looks like this, and when I print out C, it looks like that. If I ask the structure of B, and I ask the structure of C, and I ask the structure of the original A, they all look very similar. The only way we can tell that these are matrices is that over here in the brackets, it says 1 comma 1 through 10, and over here it says 1 through 10 comma 1. So this is an indicator, because there's a comma in there, it says you've got 2 dimensions, all right? Whereas the original A itself there's no comma in there, we only have one dimension. Okay, and when it prints out, maybe we see some differences here, but these are all this. Okay, RStudio does an interesting thing. If it's a vector, it says values, and then as soon as you have a second dimension to it, it throws it up in this category called data. Okay, and so B and C are thrown there. Okay, so it says, as always, you can use str, the structure, to reveal the differences. All right, one-dimensional vector, structure of f is that. Oh, if you asked all of this, column vector or column matrix. Okay, so all of this stuff here. So if I say is dot vector A, it'll say true, but is dot vector B, that will be false. Is dot atomic for all of these, I think, will return true. Okay, so they're still atomic data types, but as far as are they vectors, when they're turned into matrices, they're not. Okay, and if you say what's the class of A, it'll say integer. Class of B, matrix. Whereas type of A will be integer. What's type of B? Also integer. Okay. All right. So matrices would be the two-dimensional extension or a multi-dimensional extension of atomic vector types, where everything is the or atomic data types where everything's the same type. If you want different heterogeneous things like a list, then you have to deal with the data frame in a two-dimensional structure. Okay, and so with the data frame, data frames are essentially lists, and you can create them using the command data.frame. All right, and so we can say data frame X will be the elements 1 through 10, and then Y can be letters, the first 10 letters. Okay, and there you go. You have a data frame now. Let's store this as let's call this df. Okay, and then so df is this. We can ask the structure of df, and it will say it's a data frame. We can ask the class df. It will say it's a data frame. What do you think type of df will return? It'll say it's a list, okay? Because that's what it is, okay? It is a list. It's just we have two lists, or two elements in the list, okay, that each have 10 things in it, okay? And so we can display it in kind of this rectangle form, all right? And then, and because it's a list and we have names, you can use the $sign notation this way. All right, $X to get that. Okay, so that's what we have. You'll notice that when I ask for the structure of df, it says y is a factor with 10 levels. Maybe that's what we want. Maybe that's not what we want. Okay, if you didn't want that, okay, then you have to do strings as factors equals false. Okay, and then now it looks almost the same, except if we ask the structure of df, it will say we've got integer data and character data now, rather than factor data that we had earlier. Okay. So df $y here, this is just a character thing, whereas before it would have displayed as a factor. Is that okay? Do I need to slow down here? We're good.
Can you go over that again, actually?
The factor part or the character part or the?
Yeah, the character.
Okay, so data frame at the default setting is to treat your strings as factors. Okay, and so if you see character data, it's going to turn it into a factor. Okay, so here we brought in ABC, and it's created a factor with 3 levels ABC, And so the underlying data is stored as 1, 2, 3, as integers, okay? If we didn't want it to be handled that way, then we would have to use this option, strings as factors equals false, and then it just preserves it as ABC, okay? And so this is character data, and it's not integer data with levels assigned to it. Yes?
How would the output look when if you go back to the R,
Mm-hmm.
when you printed out $y, how would the output look if it was still a factor?
It will look just like a factor. So if I take this off and I produce df and I did df $y, it'll look like this, but it looks the same, but it comes with this thing that says levels, right? And then so if I ask, type of df $y, it'll say integer, okay? And if I say class on this, it will say it's a factor, okay? And if I wanted to just replace maybe the last thing in y with the letter m, it's going to give me this thing, okay? Whereas if I changed it to strings as factor, all of this stuff, df $y, this is now character data, and we can see it because it puts the little quotes here. And so now if I wanted to df replace the 10th one with the letter m, it's not going to complain, okay? So now the last one is none, okay? Okay, you can coerce things into data frames or lists or all of that stuff, and you can check is something a data frame using is.dataframe and all of that. You can, if you coerce a vector into a data frame using as.dataframe, a vector will produce a one-column data frame. A list will turn into a data frame as long as the things in your list are all of the same length, okay? So let's say you have, 3 things in your list. The first one maybe is a character vector with 10 elements. Then your second thing, if it's an integer vector, it also needs to have 10 elements. If it has 9 elements, as.dataframe is going to complain to you and say, like, what are you trying to do? With a matrix, it will just turn the matrix into a data frame. No complaints. If you have names, if you have column names in your matrix, that will be preserved. Okay. And if there are no column names in the matrix, it's going to assign them for you. So here I've got X. It's a matrix A, B, C, D, and I can do as.dataframe X, and it looks almost exactly the same, but this is now a data frame. Okay. And kind of the only indication is that we no longer have this bracket stuff, and now has created kind of like row names, and this is now a data frame here. If I made Y a matrix of the elements 1 through 20, and I said number of columns is 4 again, here I have Y. There are no column names. I can do as.dataframe Y, okay, and it just auto assigns some variable names: v1, v2, v3, v4.
What matrix has row names?
I'm pretty sure the row names will be preserved for when you do that. So I think X is now okay. So X is still a matrix here. So if I did row names X, we'll use the capital letters. We'll use letters 11 through 15. Okay. So X, oops. Okay, X will look like this. I think if I did as.dataframe, I think it preserves that. Yeah. Okay. So now you really can't tell what's going on here, but so let me just store this as XDF here. Structure XDF. This is now a data frame, whereas if I asked what's the structure of X, it recognizes this as still a matrix. Okay. Okay, I guess we're running out of time. Combining data frames works very similarly. You use cbind and rbind. Okay, you can do that. This is one thing that's important when you're trying to combine vectors together to make a data frame. Don't do cbind first and try to throw it into a data frame, because if you do cbind on vectors, it tries to make everything the same data type because it's trying to make a matrix. So if you want to preserve kind of the different forms of the vectors, just use data frame directly. Just do data frame, v1 is this vector, v2 is this vector, v3 is this vector, and that will produce the data frame that way. Don't c-bind the vectors first, okay? And that's pretty much it. Okay, so we'll see you guys on Friday.